Hi, I'm Jenna Milligan, and I'm about to graduate with a Bachelor of Science in Mathematics with a minor in Statistics. For my senior research, I chose to do an honors project that combines both of these interests. My project is titled Algebraic Methods in Probability and Statistics and follows the work of Seth Sullivan in his textbook, Algebraic Statistics. Before I get further into my project, let me talk just a little bit about math in general. In most fields, research involves trying to discover or create something new. In my experience in math, research involves trying to understand the work of other people. And as math dates back thousands of years, there's plenty of work to try to understand. This leads to one of my favorite math quotes by mathematician von Neumann. He said, "In mathematics, you don't understand things, you just get used to them." Obviously, this is a hyperbole, but there are definitely points during my year-long project that I felt this was true. With that in mind, I'm going to try to give you an idea of what my project is about, while keeping it at a level accessible to those of you who aren't quite as used to math. Consider flipping a coin 2 times. We are interested in the number of times the coin turns up heads. We're going to denote the probability of the coin being heads by the symbol pi. If the coin was fair, pi would be 0.5 for 50% chance of getting heads. Let p sub k be the probability of k heads out of 2 flips. We know we will either get 0, 1, or 2 heads, so we will have 3 different probabilities. We write these probabilities as the point p0, p1, p2. There are 4 possible outcomes: heads, heads, tails, heads, heads, tails, or tails, tails. Assuming that these flips are independent, we can easily find these probabilities based on the outcomes and using the probability pi. We will give 2 descriptions of all points p0, p1, and p2 that arise from such coin flipping situations. First, we note that these probabilities depend on pi, so we can create a parameterization of these probabilities as a function of pi, which is given by phi, shown here below. The resulting points are valid probabilities if pi is between 0 and 1. Using algebraic techniques, we can show that all valid p0, p1, and p2 also satisfy the equation 4p0 times p2 minus p1 squared equals 0, if p0, p1, p2 are all greater than or equal to 0 and sum to 1. We can represent the zeros of these 2 polynomials with an algebraic object we call a variety. A large focus of my project was representing other probabilistic situations in this way with algebraic techniques, focusing on how approaching these problems algebraically can yield new results. Say that we don't know pi, but we know that we flipped 2 heads. Another area of focus in my project was using algebraic methods for finding the maximum likelihood estimate for parameters like pi, which maximizes the likelihood that a set of data occurred. And that's about all the time that I have. I hope that you enjoyed this preview as much as I enjoyed doing this project.